We're going to talk a little bit about deep agents for the people here that are here for the first time, not familiar with them as a concept, and then we'll talk about what it takes to actually take deep agents and effectively deploy them into production. So, going to start at the basics, where we normally do, which is what are deep agents? And deep agents are a harness. If you've been following the AI space, you've probably heard the word harness thrown around a lot in the last couple of months. And the first question that you might have is, what is a harness? Well, the easiest way to think about it is that when you have an agent, whether you're building it, you're talking about it, you're testing it, the agent is a model, a foundational LLM, plus a harness. And so, again, the easiest way to think about this equation is that if you're not the model, you're the harness. And so the harness is everything that's built around the model to make it useful, to make it reliable, to make it good. So if you use Claude Code, Claude Code has something like 500,000 lines of code as part of its source code. All of those 500,000 lines are part of the harness. And so all of those lines are designed to make the model under the hood, whether that's Opus, whether that's Sonnet, whether that's something else, perform the best possible way that it can given your task. And so what actually goes into that code? Well, there's a couple of different classes of sort of primitives that we see building up the harness. So a big one is going to be system prompts. That is the main interface that you have with your LLM, as well as memories. This is how you have your LLM learn over time. There's a lot of buzz right now around dreaming and continual learning and having your LLM slowly tune itself to your preferences. This is usually done through memories. Same thing with tools, skills, MCP, and subagents. All of these things that are normally part of your agent, your orchestration, are also considered part of your harness. So any of the infrastructure that you use, any of the orchestration, so file systems, sandboxes, your browser, anything that the agent interacts with as part of the interface is also part of the harness. Now, the last thing that is a little bit unique to deep agents and is useful is the idea of hooks and middleware. Deep agents allows you to define your own middleware to intercept calls to the model, either before the model executes or after the model executes, so you can add in your own custom logic, things like guardrails, things like extra pre-processing or post-processing, or whatever you need to get that optimal performance for your given task. So what's included in deep agents harness? So the way that you can think about deep agents is that it includes best practices when it comes to harnesses out of the box, and it's open source. So Claude Code is closed sourced if you don't count the leaks, but deep agents are fully open source. And so what that means is that you can tune deep agents as a harness to your specific use case, your specific task, and it includes a few core primitives that allow you to pull different levers and, again, adjust your performance. So one of the biggest ones that you've probably heard me talk a lot about if you've been at previous meetups is the file system. The file system is probably the state of the art when it comes to context management today, where agents will utilize the file system to store information that they might need to reference, such as a scratchpad. And because foundational models have been trained on so much file system data in the course of optimizing Claude Code and Codex and coding agents, foundational models are very, very good at utilizing the interface. So giving your data to your model in the form of a file system tends to boost performance. Now, there's a lot of other things like summarization, subagents, and planning that are really centered around context management that deep agents exposes to you so that you can effectively control what information makes it to your model. And so only the minimal amount of information passes to your model as needed, so you can extend your context window and you can keep your model focused. And so if you're familiar with LangChain, which I hope you are attending this event, when compared to the rest of our open source packages, you can kind of think of the layers of abstraction as follows here on the screen. So deep agents is the highest level of abstraction. It's the most abstracted sort of interface for building agents. It's built on top of LangChain, which gives you that basic tool calling infrastructure that people refer to as agents today. And under the hood of LangChain, everything is built on LangGraph, which is the core Lego pieces that you use to put everything together. This is the nodes, this is the edges, and this is the state. So deep agents is the highest level of abstraction, and it's the way that you can get started the quickest if you want to get an agent up and running in production as soon as possible. And so now that I've explained what deep agents are. I'll talk a little bit about why they're useful before we get into the production considerations of running deep agents. Again, I want to re-emphasize at this point that deep agents give you the tool calling framework that is kind of a standard these days with best practices built in. And so one of the most convenient things about deep agents is that it is very easy to extend any of your existing tool calling agents and turn them into a deep agent. So if you have a tool calling agent using that classic React architecture, an example might be here up above if you're using LangChain. It's very easy to turn this into a deep agent. And so if I have this basic research React agent where it has an LLM, it has some tools to search the web, maybe it has a guardrail at the beginning, and maybe it has some summarization at the end, I can very easily turn this into a deep agent by switching out the instantiation from create agent to just create deep agent. And what create deep agent will do is that it will add these pre-built primitives to our tool calling loop. So it'll add middleware that adds support for a file system. It will add middleware that adds support for a planning module. And it will also add pre-built tools to navigate that file system. ls, cat, grep, you name it. And it'll add things like a subagent tool too, so that your core LLM can dynamically spin up subagents. And because everything under the hood is built on top of LangGraph, this also means that deep agents is deeply composable with any of your existing LangChain or LangGraph agents. You can have a fully deterministic LangGraph workflow utilize a deep agent as one of its nodes. So you can have a fully deterministic sequential workflow that uses deep agents to handle one particular complex reasoning step in the middle. Similarly, you can have a deep agent coordinate deterministic flows under the hood as subagents. And so really, no matter what your use case is, you can find the right way to mix and match deep agents with more deterministic LangGraph code. And this really lets you find the sweet spot that's useful for your task and your use case. But in general, the direction that we're heading is that models are getting better, and the basic deep agent harness is also getting better in terms of performance. So if you think about reliability and agency as sort of this Pareto curve where before, maybe a few years ago, you could have high reliability, but you would neuter your model's ability to flexibly handle different tasks. You could also make the trade-off to have your model be very agentic, but then it probably wouldn't be very reliable for a lot of the most significant mission-critical tasks you wanted to deliver. Well, the pattern that we've seen in recent years and recent months is that this curve keeps getting pushed outwards, which means that your basic harness, your basic tool calling loop is getting better and better, more and more reliable, where for a lot of the use cases that you might be wanting to build today, a vanilla deep agent is fully capable of handling it very reliably end to end. And so our recommendation when it comes to building agents is to always start with a deep agent. So now let's finally get to the portion where we talk about what it means to run these agents in production and what are some of the special considerations that you might face when you have an agent in production. Standard infrastructure, in short, is not really built for long-running complex agents. It's not really built for deep agents. And so it brings some additional production considerations if you want to be deploying these agents and using them for significant tasks that are relevant and important for your business. So some extra considerations that you have to think about is that lots of deep agent use cases are long-running. They're multi-step. And because they're long-running, you do need a good way to handle errors. It's likely that the longer your task is, at some point your agent is going to fail, and it's going to feel really bad if you're on step 67 out of 123, and then you have to execute all the 67 steps again when you restart the task. Same thing with auto-scaling or parallel fan-out, resuming dropped sessions and incorporating human in the loop. There's a lot of the different considerations that you have to think about up here on this slide if you are using agents in production. And so your runtime needs to accommodate deep tasks or complex tasks or deep agents. I'm saying the word deep a lot, but you get the point of where I'm going. And so let's take a look at some of the specific considerations, zooming in on some of those from the list that we found most important when we were building our production agents at LangChain. So one of the first ones that I mentioned was durable execution. As we noticed our agents getting longer and longer running, we noticed that we do have this problem where you need some way to recover from failures, because one of the core patterns of agents, again, is still that they're limited by their context window. And a lot of the innovation around harnesses today is about maximizing your context window. So by nature of building a complex agent, you are likely going to be pushing your context window to the limit. You're going to be running things for very long periods of time. And somewhere in that process, as you get pushed to the limit, it's more and more likely for your agent to hallucinate, for your agent to fail, or for it to encounter some other error. And so it's very important to be able to recover from exactly that same spot where you had the error occur and not have to restart the task all the way from the very beginning. And so this is something that is supported within our open source frameworks, LangGraph and deep agents. We have checkpointing basically every step of your execution. So if you have a failure at step 67, you can start from step 66 and not have to go back to step 1. Another thing that checkpointing allows, and basically storing the state at every step of execution, is that if you link together all of these different associated states, you can start building this concept of memory. So if you have all of the checkpoints, all of the execution steps associated with a particular session that a user might be having with your agent, this is equivalent to short-term memory. And this is how agents today, using our open source, using deep agents, are able to remember what you said in previous turns of a conversation. Because under the hood, we're able to associate all of those same execution steps with one single session and use that to preserve the agent's memory so that it can remember if you said your preferences 5 messages ago. And you can, again, extend this across sessions to what we call long-term memory. So deep agents, when we put them into production, we always include a long-term memory store in which we will extract insights that we want to have persist across many different sessions. The most basic use case for this that you can imagine is personalizing something for a given user. So maybe your user really likes Python for a coding agent, and you want it to remember to always give its examples in Python. Those are the sorts of pieces of information that you can put into long-term memory and extract them out from all of the checkpoints that you've gathered across many, many different sessions. Now, more and more, as we're seeing agents put into production, you also have to handle authentication. And this is its own unique class of problem where not only do you have users with access to tools, you also need to consider which tools should your agent have access to. And this can be a little bit different from your standard authentication. So at the very basic level, you probably don't want to have your agent doing things that your user cannot do. So acting on behalf of the user is, through OAuth, a pretty standard flow that at minimum you need to build into your agents. But there's also new sorts of RBAC and auth scenarios that agents have fuzzy lines around that you don't really have with traditional applications. For example, if I use an application that is going to talk to my Gmail today, I can give it access to read and send emails. And if I give it that access once, because apps today are pretty deterministic, I can feel pretty comfortable that this application can send emails whenever I want. But that same dynamic might not be present for a deep agent or a more complex agent. For example, you might be okay with an agent sending 1 email on your behalf, but you might think that something's wrong and you might want to investigate if you see that agent sending 1,000 emails on your behalf. And that's a different sort of auth flow than traditional applications will see. And so this is an area that's still being figured out. You have to think about, what are your inbound authentication handlers, what are your outbound to third-party handlers that you need, and what is the RBAC that you need to be able to deploy and to work with your agents. Now, the last thing that is important that I want to call out is interfacing with users, because as of today, most tasks that are important still involve some degree of human in the loop. There are cases where you can fully run something autonomously end-to-end with an agent, but many cases today you will still want to have some degree of human oversight. And so this is something that needs to be built into your runtime and needs to be supported at a very foundational level for your agents. So with deep agents and with LangGraph in our open source, this is a core primitive that you always have accessible to you. And so if you deploy anything in production with deep agents or any of your own agents, you should consider, how is my human user going to interact with this agent? How can my human user interrupt or stop or approve whatever the agent is doing? And one of the core pieces of infrastructure is also, how can I stream the agent's progress back to my human user? Because oftentimes these agents will be running, like we said, for long periods of time, and you want to keep the human updated as to what the agent is doing and if it is still working. And so these are all considerations that you have to think about if you're putting complex agents into production. It wouldn't be fitting if we noticed all of these problems and then didn't have a solution for them. So I do have to throw in this little pitch at the end where we say, we do have these problems solved with LangSmith deployments. If you are building agents and you don't want to figure out these problems yourself, we do support deployments where you can take an agent that you've built and automatically deploy it onto our platform to handle these exact scenarios that we just spent time talking about. But again, whether or not you use our products, whether or not you're building with LangSmith, if you're putting stuff into production, you most likely will run into these same issues, and you most likely will need to have your own solutions to these issues.